Terraform state. This is a file, stores the current state of the infrastructure, managed by Terraform. It acts as a snapshot of your resources. This file, created by Terraform itself, when the first Terraform apply command execute. After that, whenever the apply or Terraform destroy command runs successfully, the state file update once to tracking the current state of the infrastructure. Terraform state file is created in the form of metadata, and stored in the local Terraform workspace. This is an example of a state file after successful execution of Terraform apply, and this one is the same file changed, after destroy the infrastructure. Why the Terraform state is important? Terraform state is the main functionality that distinguish Terraform from other IAC tools. The main objectives to keep state file is 1. Infrastructure tracking, 2. Change detection, 3. Resource dependencies, 4. Collaboration. Now to store the state file, there are two specific ways. 1. Local state, where the state file stored as a file in the local Terraform directory, and 2. Remote state, where use some backends like AWS S3 to store it, as an enhanced secure and centralized approach. The general use case for the remote state file is, in a shared environment, where multiple DevOps engineers are working in a same project can update in same state file accordingly. The remote state file can be pulled with Terraform state pull command to clone it to the local repository. Now I am providing a demo for remote state file generate and store in a AWS S3 bucket. I am using an Ubuntu system to run the Terraform script, which will create an AWS EC2 instance, with other dependencies like VPC etc. and create the Terraform state file, and store it to the remote S3 bucket. Just we have to extend the configuration in main.tf with the backend resource block, where we need to mention the bucket name with key, for the directory for the file under the bucket, and region where the bucket will create. Once we run Terraform apply after init and plan command, it create the state file, and store it to the location. See the demo now. This is the existing main.tf file, where we have added the backend resource block, and this is the AWS S3 bucket, with the directory name, remote in EU Central Region. With Terraform init, Terraform start the workflow by download the necessary plugins for the backend from AWS Cloud Provider. Now Terraform planned give the detailed information of what Terraform is going to create once Terraform apply will be executed. Here it is. And once the Terraform apply command finally run, it creates all the resources, along with the state file, and store it to the remote backend, that is AWS S3 bucket as per the backend configuration. During the validation we can see it successfully stored the terraform.tfstate file in the S3 bucket under the remote directory. Here it is. Now there is a genuine possibilities with the scenario where many developers are working with the same state file, and trying to update the state file simultaneously. To avoid the conflict of errors, there is a features called Terraform state locking, where the state file is locked by a locking ID, till the modification of state file is completed. Once it is complete, then the state file will be released, and other developers can able to update it accordingly. The main component for this state locking features are DynamoDB table, where the lock ID is mentioned. This lock ID is lock the state file during the time of one using the state file. Once the modification has been completed, then the lock has been released and other user can able to start the modification. Now coming to the configuration part. The features may look complex to enable the locking to the state file modification at one time, but the configuration is quite simple and straightforward. In order to achieve the security and implement the locking features, we create a DynamoDB table and mention the user-defined table name just under the backend configuration. Once the table name has been specified in AWS DynamoDB table, you need to specify the partition key. Please note that the value for the partition key will always be lock ID. You need to specify only this name, lock ID, over there. Once done, just click on Create Table. Once table created, you need to specify the table name in every Terraform workspace. You need to use this state locking features. Now in the live demo, I will open the DynamoDB table by search the keyword DynamoDB in search field of AWS Web Console. Once appear in the search, I will just click to open it. Once open, I will provide a unique meaningful name from my own, and followed by the name lock ID, in the field of partition key. Once done, I will just click on the Create Table option mentioned below. It will create the DynamoDB table, which will show with an active status. Once the DynamoDB table has been created, we need to specify the table name in the backend config block of the main.tf, where you need to enable this state locking features. Just open the respective Terraform workspace, and open the main.tf file. Just mentioned the argument dynamod_table, in backend S3 block, and assign the name, which is Terraform lock table in our case. Once done, just save the file. You have completed the state locking configuration. Now you can use these features to lock the Terraform state file, so any other developer cannot overwrite the same Terraform state file during the time of execution of Terraform apply from your workspace. Even the developer cannot execute the Terraform plan command simultaneously till the end of execute your apply command. This feature saves the Terraform state file from incorrectly overwrite. Thank you for watching. Please like, subscribe, and share if this content is add any values to your knowledge.